Okay. Hi all, I'm Guru Shetty. I work at VMware. Over the last couple of years, I have been working on Oven's integration with containers, and today I'll just talk a little about what is it that we have done. So the first question is, what does it even mean when we say that we want to integrate OVS with containers? Containers, at least from networking perspective, at the very basic level, is just a network namespace. So the question is, how do we integrate a network namespace with OVS? It's very straightforward and simple, actually. You create an OVS bridge, you create a namespace, and Linux has this network device called a web pair, which has two ends. You create it, you move it inside a namespace, rename it to something which is familiar for people looking inside the namespace. In this case, it's renamed to eth0, and then finally add it at the other end of the web pair to the OVS bridge. So it would look something like this. So inside the namespace, it looks as if it's a VM. It has its own networking stack. You send a packet out, it just hits OVS, and then you can manipulate your packet. So you do the same thing on a different namespace, and now suddenly your two namespaces, they can speak to each other over IP address as long as the IP addresses are in the same subnet. The reason it has to be on the same subnet is because by default OVS is switch, so if they're on the same subnet, they can just speak to each other. So the second question is, what does it even mean when we say we want to integrate Oven with containers? So when you have hundreds of hosts, it sort of does not make sense to go on each individual host to manipulate OVS, and you want higher level features, so you need an SDN solution. So in case of Oven, it provides that. So to integrate Oven with containers, in the previous slide, we just showed how to create a web pair and add it as a port to OVS bridge. So for Oven, we just associate a metadata. For example, I have given the name port 0. It's just a string. We add it to the vSwitch bridge. And then in the Oven's database, we can create a logical switch and then add a logical switch port with the same name as in the previous step, that is port 0. We give it an IP address and a MAC address, and that's it. Oven will program OVS and let traffic come from that particular namespace. So if you have another host, you can create the OVS port with the same name. So the port name is very local, but the metadata has to be unique. And then you add this new port. In this example, it is port 1 as port in Oven. Give it an IP address and MAC address. Oven will do the programming. And now the namespaces, even though they are in different hosts, they can communicate with each other over IP address because Oven creates a tunnel. Now the third question is, what does it mean to integrate Oven with container orchestrators? So managing, deploying, and maintaining the life cycle of thousands of applications, it's hard to do it application at a time. You need someone to maintain them. You need someone to help the applications discover each other. And the container orchestrators take care of all of that. And when we talk about Oven's integration, we want it to be seamless. We don't want people using a container orchestrator to run some container orchestrator commands, and then he comes to the back end and starts running Oven commands. So it should not be like that. It should be one step. So let's take the example of Kubernetes. I'm not sure how many are familiar here, but this command says to Kubernetes that I want to create a pod. A pod is a group of containers which share the same network namespace. So from networking perspective, it's just one container. So the Kubernetes scheduler will decide, hey, I have this empty host. I'm going to schedule my pod out there. And if you have OVS installed there and an integration bridge created, then Kubernetes will create a pod. It does not yet start the application. It then calls Oven plugin, which is standardized, and passes it some input. It says, hey, I have this pod. its name is so-and-so, and it belongs to this namespace. Now it's your responsibility to configure networking. So Oven's plugin will just create a web pair, add it to OVS integration bridge, give it a metadata, and make Oven calls to create that logical port. And when a pod is deleted by Kubernetes, we just do the reverse things. We say delete the web pair, delete the open vSwitch port, and clean up Oven's database. All right, so now getting it a little deeper. So Oven, as Russell explained, over the last 2 years has added a rich feature set. A container endpoint can be your logical switch port. You can have multiple logical switches. You can then connect them with a logical router. You can add firewall rules, which is distributed. You can do load balancing, which is again distributed. DHCP, DNS are again distributed. You don't need to go to a server. Your packets will get intercepted by Oven, and the response will come back. The last is gateways and NAT. These things are not distributed. They are sort of host specific, and they are useful for your cluster traffic to exit the host. All right, so 2.5 years ago, when we started the Oven's journey, Docker was all the rage. Everyone was speaking about Docker, and everyone wanted to integrate with Docker. In the previous slides, I was talking about how simple it is to integrate with Oven, but frankly, when we tried to integrate with Docker, it was very, very hard. It took almost 6 months to finish the integration, and the main reason being the amount of data that Docker would provide Oven was very limited and restrictive. So all your time was spent on convincing the guys at Docker that, hey, we need this data because otherwise we cannot integrate. And then came Docker Swarm, and they changed their APIs. So what used to work with Docker does not work with Docker Swarm. But luckily, Kubernetes caught on. It's right now the most popular orchestrator. They are very open about data sharing. So your network plugin gets whatever it wants to. It can do whatever it wants to. So there is a much better seamless integration with Oven. We've also worked with the guys at Mesosphere to integrate Oven with DCOS. But since Kubernetes is our most mature integration, I will spend time talking about that. So I'm sure not everyone is familiar here about Kubernetes networking, so I'll just spend some time talking about the Kubernetes networking requirements. So a pod in Kubernetes is the most basic deployment unit. It's just like a VM. And from networking perspective, it's just one endpoint, even though there are multiple containers. Since there are multiple containers in the same pod, they can talk to each other over localhost. They can use 127.0.0.1, and the traffic will not hit Oven. It just happens inside the pod. A host can have multiple pods. It's really up to Kubernetes on where to schedule their pods. And when they speak to each other, they have to use their own IP address. So the next one is important. In case of OpenStack, which is a truly multi-tenant system, you can actually have Coke and Pepsi right next to each other. They can have the exact same IP address, and they can't talk to each other. But in case of Kubernetes, that's not the case. Everyone should be able to talk to everyone else in your cluster, even if it is 1,000 machines, and they should use their own IP address. And each pod should also be able to speak to Kubernetes daemons, because those daemons provide them some services. And unlike VM, wherein we are used to VM migration across hosts, there is no concept of container migration. You don't like a pod, you just destroy it and create it somewhere else in a different host. And they have a load balancer in front of every pod. So you have a group of pods, and if you don't like one, if it's not healthy, you just destroy it and create one somewhere else, and things will just work. So how does Oven's networking for Kubernetes look like? In this slide, I have 3 hosts. There is a master where Kubernetes daemons run and also Owen's databases run. And the other two hosts are called minions. So that's where Kubernetes schedules its pods. On each of those minions, we have a CNI plugin. Its job is to create the web pair, attach it to the OVS bridge, and provide information to Owen's database for the network configuration. Owen controller, in turn, on each host will program the OVS instance for connectivity. We also have one node on each host, one interface on each host, which only does health checking, which is a Kubernetes requirement. So that physical network in the previous slide, the physical topology in the previous slide, how does it translate to the logical topology in Owen? So before Kubernetes schedules any of the pods, we do some initialization. We create a cluster-wide distributed router. And for each host, we create a logical switch. And in case of master, the master gets attached to one of the logical switch. So that way, the master can now speak to the whole cluster. We have health check interfaces in the virtual topology too. That way, the daemons can health check whoever is in the logical switch. And when Kubernetes starts scheduling the pods, they just get attached to the logical switches on that host. So now, all the pods can speak to all the other pods. They can speak to the master node, and health checking is possible. So this takes care of east-west connectivity. But if the traffic from your pods, if it has to leave your cluster, it has to go outside, or someone outside the cluster wants to talk to the pods inside, you need the north-south connectivity. So for east-west connectivity, as explained in the previous slide, you have a router and a bunch of logical switches. For north-south connectivity, we have this idea in Owen called gateway routers. These are host-specific, and their IP addresses, which are external facing, are your real physical network IP addresses. So in case of VMs, this would be your VM IP addresses, and in case of bare metals, it could be your floating IPs. And then we create this join logical switch, and once you do that, the pods can get out of your network via any router, and traffic can come into your network via any router. So you have full connectivity. On the gateway routers, we do NATing and load balancing, so that when packets go out of your cluster, it has a sort of public IP. So Kubernetes has a lot of more requirements, and previously we just talked about networking. So we use something called as a Owen watcher. The Owen watcher's job is to keep continuously watching the Kubernetes API server. It gets notifications. So everything that you do in Kubernetes, it gets stored in the API server, and you can get notified when something happens. For example, when Kubernetes creates a pod, you will get a notification, and you can create a logical port in Owen. You can ask Owen's IPAM to provide IP addresses back to you, and then we annotate the pod object with the IP addresses. Now, when the pod actually gets created in a minion, you know its IP address, and you can just configure it there. As mentioned previously, in Kubernetes, everything is reachable via load balancer, even for east-west traffic, which means that the pods backing the load balancer can change. So you can create and destroy pods, which means that the IP addresses of your load balancer endpoints will change. But we get those notifications, and we go ahead and change Owen's load balancer entries. Kubernetes has also this idea of network policy. So it has this soft multi-tenancy, wherein even though all the pods by default can speak to each other, you can say that, hey, I have this group of pods, I don't want anyone else to talk to it, or I have this group of pods, I only want to open this specific TCP port. And whenever the network policy changes, Oven's watcher gets a notification, and it will configure Oven. So in OpenStack, where Oven really shines, it mainly shines because of its inbuilt ability for multi-tenancy. In general, because this is a network virtualization solution, you can have Coke and Pepsi next to each other with the same IP address, and Oven does a very good job of making sure that they can't talk to each other. But Kubernetes has this sort of single tenancy model, and they want to use firewall rules to prevent people not to talk to each other. Now, many people have tried to push this multi-tenant model into Kubernetes, but the maintainers feel that Kubernetes is more of a application orchestration tool rather than an infrastructure orchestration tool. And if you really want hard multi-tenancy, you just create multiple clusters. So the other thing that everyone talks about these days is service mesh. The general idea is that when a packet leaves the pod, it will hit an IP tables entry inside the pod, and it will get redirected to a L7 proxy. The ride-sharing company Lyft open sourced their L7 proxy called Envoy, and it has really caught on. So it provides you all this layer 7 related services, but the penalty is that each container needs to have Envoy proxy. Envoy itself is controlled by a central authority called Istio, and your packet will hit the Envoy proxy before it hits Oven. The Envoy proxy will do layer 7 services like load balancing. It can do authentication, even encryption, and things along those lines. But for Oven, once the Envoy proxy sends its packet, the normal network routing still takes place because the packet needs to go to the destination pod. Your L3 and L4 firewall rules would also work. So the code is all in Open vSwitch repository. And there is a bunch of development opportunities for people who wants to contribute. We have some rough edges which needs help cleaning up. So anyone interested, please reach out, and we can code together. And that's it. I guess I finished early. Yeah.
All right, thanks, Guru. So we have time for questions. So anybody with a question, come up to one of the mics on the side, or reach out to me, and I'll run one over to you.
Well, not a container crowd.
That's a surprise. Usually containers as the trendy thing would get a lot of questions. Ah, there we have one.
Thank you so much, Guru. This is really fascinating. I'm still new to this, even Kubernetes and Open Kubernetes code, but what was the reason you create that Open virtual switch per Kubernetes node? Do you have any behind-the-scenes stories why you picked that, or instead of sharing those virtual switches across multiple Kubernetes nodes?
So the question is, why have one switch per host instead of a single switch across the entire cluster, right?
Yes.
Yeah. So I think the general idea was that if you have a 1,000 node cluster with 10 ports in each, you are looking at 10,000 ports on a single switch, which can become a big broadcast domain. So the idea is to split your broadcast domains to smaller pieces. So it just made sense that having one switch per host just makes more sense. I mean, there was no hard and fast rules.
So we can go even in the middle of that, one virtual switch to take care of, let's say, 10 Kubernetes nodes.
Yes, so it would really depend on your choice on how you want to do it. But the default scripts do one switch per node. But Oven itself, of course, is capable of flexibility. You can do pretty much anything you want to do.
Great, thank you.
Sure.
Do you hear me?
Yeah.
Okay. So do you have containerized your services for the Kubernetes?
What's that again?
I mean, do you have containerized your services for the Kubernetes? I mean,
Do I write services for Kubernetes?
so they're containerized?
So these are, Oven is not. So Oven still runs on the host.
Okay.
All the Kubernetes pods run as containers. So we don't containerize it yet.
Thank you.
Hey, Guru, thanks. You talked about Envoy and Service Mesh. Is there any challenges here having two masters, Envoy and OVN, and conflicts? And
Not
also-
really. So Envoy is trying to do everything at the layer 7 level. And the basic networking still has to be provided by someone. Now, if you are in specific cloud providers wherein they provide this per container networking, you probably don't need Oven, but it's still useful to have Oven for firewalling. You want to do distributed firewall and things like that. So I think both are needed, but if, for example, Envoy encrypts traffic, then you do not have visibility inside it, but you still have the headers to do L3 and L4 based load balancing.
The follow-on, could Oven become more of a service mesh?
What's that?
Could Oven become more of a service mesh?
I think it's generally harder because OVS kernel module cannot be converted into sort of a thing which can look at layer 7 type of things. If DPDK had worked with containers, then that would have been a perfect fit, but it doesn't. So right now, we are stuck with the layer 7 proxy.
So would you say that, in your opinion, is Docker kind of chilly or lukewarm on Open vSwitch? Or because my perception has been in the literature and at the conferences that they don't really leverage Open vSwitch too heavily at Docker.
I don't think they're chilly just specifically towards Open vSwitch. I think Docker as a company has a business to run, and they're generally they want to be careful with what they pursue as competition. So they tend to control their APIs, and that's the perception. And I think that perception exists in the industry, which they're trying to change. But it's also possible that Kubernetes gained so much popularity because of that perception.
Yeah. So I mean, and of course, they just announced that they fully support Kubernetes now,
Yeah.
side by side. with
Right.
Swarm.
So I think they had to do it because customers said that if we go with Docker, then everyone is speaking about Kubernetes. Will we get locked in? And Docker just wanted to remove that conversation. So they just said that we'll do Kubernetes and Docker Swarm. I mean, that's my opinion, of course.
Yeah. So I mean, not to press the point, but I mean, so how would you kind of characterize their relationship with OVN and Open vSwitch?
I don't think they care much. I think they are at a much higher level, and because OVS and OVN is not a commercial solution, they just don't see it as a competition or anything else.
All right, we have time for one final question.
OpenStack can work with OVN, and Kubernetes also can work with OVN. So what if OpenStack plus Kubernetes with VPN, OVN?
I did not follow the last part of it. What if?
I mean, if we use OpenStack and Kubernetes with OVN.
So when we started the Oven project, our idea was that you should be able to run your containers inside the VMs of OpenStack, and all the security-related things will be done in the hypervisor, which again is Oven. And the switching and routing again will be done inside the hypervisor, which avoids this problem of double overlay. But I think the OpenStack community probably did not warm enough to that idea, so that did not go too far away. People still talk about that kind of integration, but I think it's sort of in the back burner.
Let's thank our speaker.